Assalamu alaikum dear students. Here we are with our AS chapter number 2, and this chapter is we have already mentioned that here we have chapter is kinematics, and we have actually previously 2 lectures of this chapter. So if you want to see or go through those chapters, I think it 2 lectures, then I think it will be a better understanding for you. So as I said that this will be our 3rd lecture of this chapter number 2. So this is lecture 3 of this chapter. And here we are dealing with the displacement time graphs. Basically, if you have any question, there may be 2 aspects as far as the graphs are concerned. One is that they have given you a description of the motion, meaning they have given you the description, they have described the motion Number 2, describe the graph. They will give you the graph. So you can write that here we have, this is something which is given. So the graph is given, and you have to describe the motion. And on the other hand, they have given you the motion, and then you have to describe the graph for that motion. So these are 2 possibilities. Here we have the first situation where the graph is given, and we have to describe the motion. In this case, the most important point to remember is this one. Yani, gradient of ST graph is velocity. You know that as far as the velocity is concerned, we have defined this term in our first lecture of this chapter, and velocity is nothing but rate of change of displacement. And you know that rate of change of displacement or rate of change with respect to time is nothing but the gradient. So you can say that if we have a graph between the displacement and time, then the gradient of the graph will give us the velocity. So this is the most important thing. Here we must remember one thing, that if we have a body which is you can say at rest and it starts moving, then initially the body must have an acceleration. Yani the velocity will, you can say, increase from 0 to a value. And here, like suppose you can say and see that we have a situation that suppose at this point the gradient is 0, so the velocity is 0. But over here, if you will consider another point, then you will see that the gradient has increased, yani velocity has increased. Similarly, if you will consider another point somewhere here, then the gradient will be even greater or a higher value. Similarly, for other points, like suppose here you have another point somewhere here, then the gradient is increasing. So you know that for all these points which we have mentioned, like 1, 2, 3, 4 points, all these points have different gradients, and gradient is increasing. So the velocity is increasing, and velocity increasing means that the body is accelerating. So this is very important, that when we are going from suppose point O to A somewhere here, and the time taken is t1, so you can say that during this time interval the body is accelerating, yani the velocity is continuously increasing. Now from point A to point B, where you have this part of the graph A to B. Here you can say and see that almost this line is a straight line. So when you have a straight line, as I said, almost a straight line, so it means that the gradient is constant throughout this part from A to B. So when the gradient is constant, it means the velocity is constant. So this is what we have as far as the region A to B is concerned. And as I just mentioned, that if you are considering this time is a T2, so you can say that in between time T1 and T2, what is happening? The body is moving with constant velocity. Then from point B to point C, suppose here you have point C, this is your point C. So between B and C, what you are, you can say, finding here, that the gradient is decreasing and decreasing and decreasing. So it means that the velocity is changing in this way, that the velocity is constantly decreasing. So it means that at position, suppose somewhere here, if we are considering this point as point, say 1 in this case, 2 and 3. So at point A, the velocity was highest, yani initial velocity was highest, and then at point 2, the gradient has decreased, so velocity has decreased, and at 3, even it's decreasing. So simply you can say that the velocity is decreasing, means the body is decelerating, or the deceleration we have in between point B and C. So you can say that in between the time interval of T2 to T3, what we have, this is the situation of decreasing velocity. So simply we can say that the deceleration is taking place. Then from C to D, when you are considering point C to D, you will see that the time has increased from T3 to T4, but during this time interval, there is no change of velocity, yani the slope of the displacement time graph is 0. So what you can say, that during this time interval, the body is not moving, or simply you can say the body is at rest or has stopped. So between C and D, the body has stopped. Now this is very important to understand, that whatever has happened here from point O to this point which we have just considered, point D, what has happened, this is all you can say in the positive region of the displacement. In the first lecture I have described this in detail, that what is the positive displacement. Yani suppose if you are considering a number line, then suppose here you have 0, and on the right side you have all positive you can say numbers like 1, 2, 3, 4, 5, 6, 7, 8 and so on. So simply you can say that we can have the negative numbers on the other side, -1, -2, -3 and so on. So for the time being, what you can say, that whatever has happened here, yani this interval from O to A, and then A to B, then B to C, and then C to D, this all has happened in the positive region, and the displacement is always positive. And this is what you can see, that if we are considering, suppose this negative side of the graph, if we have this negative side of the graph, or we have this negative side of the graph, then we can say that okay, yani during this time interval what will happen, or if we are going backward or in the negative direction, then what will happen. I will show you this one as well, but for the time being the whole discussion is that we are in the positive region. So this is all positive region. So this is very important to understand, that the body was moving in the positive region, yani on the right side, yani suppose somewhere here we are. After point D, what has happened? This is important. Here you will see that the gradient is negative gradient for all these points. Like suppose if we are considering these point again as point 1, 2 and 3 in this region, yani between D and E, this is your point E, this is your point E. So during this region D and E, or the time interval here we can take as T4 to T5, what has happened in this time? The gradient is decreasing. So the gradient is decreasing or increasing. This is very important. Gradient is not decreasing, be careful. Gradient is increasing but on the negative side. So what you will say? The negative gradient is increasing. So what is actually the gradient? The velocity. So negative velocity is actually, again I have explained this in the first lecture, that negative velocity shows that we are coming back. Yani the body is coming back during this time interval D to E. And as you can say and see that the gradient is continuously increasing, yani velocity is continuously increasing, yani what is happening? Body is accelerating. So this is the most important point to remember. Here the body is accelerating between point O and A in this direction, positive direction. And in this part from D to E, the direction of motion of the body has been changed, is going in the opposite direction, but the negative velocity is increasing. So what is negative velocity in what sense? Not in sense of decrease, but in sense of the opposite direction. So what is happening in this case? D to E, the negative velocity, yani the velocity has changed its direction and increasing in its value. So this is very, very important. And what is happening because of that? Simply we can say that the body is accelerating between T4 and T5. And again the same thing, the direction of the velocity or direction of the motion of the body has been changed, but still we are moving in the positive region. You can say and see that still we have this positive region. This is all positive region. So still we have the motion in positive region. So what is happening? Only one thing, that we have moved from suppose 0, which is this point, initial point, 0 point, origin, whatever the term you are using, then you are moving towards the positive direction. And what is happening? You can describe, I have already described the discussion, the graph from O to A to B, B to C, C to D. This is all happening here. Yani from A to O to A, suppose this is the point, from A to B, suppose this is the situation, from B to C you have this part, and from C to D you have somewhere here. Then what is happening? After D you are coming back. So when you are coming back, as I said that the velocity has changed its direction, and you simply can say that what is happening in this case, from D to E, suppose this is your D to E, the body is accelerating in the opposite direction. So be careful, yani this is the time interval from T4 to T5. And then from E to F, what we are showing in this part or in this graph, here you have this situation that the graph is moving, or graph has a constant slope. So again, which graph? Negative graph. But this negative is not showing the negative velocity, is not showing the decrease in velocity, but it's showing you the constant velocity, constant gradient in the opposite direction. So you are moving from E to F. So this is what we have. Yani we have moved from 0 to say O to A to B, B to C, C to D in one direction, and then we are coming back, and the direction of the velocity has been changed, but still we are moving in the positive region. So this is very, very important. If you will extrapolate this graph, yani if you will draw this graph in this way that it's going somewhere here, then you can say that after this point, what will happen when the graph will cross this line. I will show you in another part, in another graph. This is something like this, that if the graph is going somewhere here, this is your displacement, S or D, whatever, in meter, and this is the time. So what you can say that if we have this situation, then the velocity, now here you are, this is your negative region, this is the positive region of the displacement, and this is the negative region. So still you are moving with constant velocity, but now you are somewhere here in the negative region, but still the velocity is constant. So this is very, very important. Why is constant? Because the simple situation shows you that from this point, suppose P, to this point Q, and then this point say S, you have the same gradient of the graph, and you know that gradient of the displacement time graph is nothing but your velocity. So the velocity is constant throughout this particular part. So this is very, very important, that if you are going on the left side or moving on the left side, then of course you are, or you will be in the negative region. But the main point is that, main point to understand is that you have to consider the region where you are. As I said that this whole story is for the positive region. This is all positive region. But if you will move on the other side, something like this will happen. So this is very, very important to understand. Actually, I have described this graph in theory. I have given you all these points. So quickly we can discuss this, and then I think it will be a better situation. From O to A, as I have already actually explained, the displacement is increasing with increasing rate. As we have just discussed here, that the rate is very important in physics. The rate is nothing but like a change of a particular quantity with time, suppose. So rate of change of velocity we are considering here. And then what we can say, that the rate, again I am using this term, rate is very important. So here what is happening, from O to A, you can say that the rate of change was increasing in order. Yani displacement is increasing with increasing rate. Yani velocity increases uniformly. Then if the velocity increases uniformly, simply you can say that the acceleration of the body is constant, which we have discussed in between your point O to A. So this is something important, that from O to A, the region, actually we have to consider this path, and this is the description of this path over here from O to A. Then from A to B, during the time interval T1 and T2, we have discussed already that the displacement is increasing with constant rate. And when the displacement is increasing with constant rate, your velocity is constant. So you have to relate these two things. And when velocity is constant, you know that acceleration is rate of change of velocity. So if there is no change in velocity, any initial and final velocities are constants or same, then the velocity does not change, thus body has zero acceleration. Of course, as I said that when both of these two, yani your u and v will be same, the acceleration will be zero. So this is important, and you know that we have discussed this part here from A to B. Then from B to C, how you have already explained this situation. B to C, from time T2 to T3, the displacement is increasing with decreasing rate. So this is very, very important point. Displacement is increasing with decreasing rate, yani still you are moving in the positive region. So as we have just mentioned here, that B to C, the displacement is still moving, but what is happening, simply you can say that B to C, here we have a situation where the displacement is increasing with decreasing rate, yani velocity decreases uniformly. The body has a constant deceleration. Remember one thing, that the negative velocity which you are showing sometimes will give you the concept of decrease in velocity, and negative velocity will sometimes will give you the direction concept. Yani velocity is negative means the decrease in velocity, or you can say negative velocity means sometimes the direction change. So this is very, very important. Sometimes negative will show you the direction, and sometimes this will show you the decrease. But in this region, as you can see, that from B to C, what is happening, there is a decrease in velocity because the decrease in gradient. So simply you can say that the deceleration is taking place. And this is what we have written in the third point. The body has a constant deceleration. Then from C to D, from T3 to T4, the displacement is not has not changed, has not changed. So simply what you can say, that the displacement has not changed, that is the body is at rest, and velocity is 0, so acceleration is 0 as well. And this is the region we have from C to D. Over here, as I have mentioned, from C to D, but you know that as the body is not moving, so C to D, the displacement is not increasing simply, but you can say that we are just mentioning C to D to show 2 points or the time interval from T3 to T4. So this is very important. And then of course you are coming from D to E. This is just to show you this region D to E. But of course you can say, as far as the displacement is concerned, we have the maximum displacement on the right side at point C. This is the point where the maximum displacement you will have, and after point C till G, the displacement will same, because the body has stopped during this time interval. So this is very, very important. Then from D to E, what has happened? The displacement is decreasing with increasing rate. Again the same thing, displacement decreasing doesn't mean that the displacement is negative. Displacement is decreasing means that you are coming back. So displacement is decreasing. So this is very important. Yani decreasing from where? From your origin. Yani the body is coming towards the origin, so the displacement is decreasing, because you know that the displacement is always taken from the origin. So this is very important point to remember, that the displacement is decreasing with increasing rate. So rate is nothing but velocity. So as the increasing rate we have, it means that the velocity increases uniformly. So this is very important. The displacement is increasing with increasing rate. The displacement is increasing with increasing rate. So this is what we have, and because of that we have you can say the velocity increases uniformly means that we have a constant acceleration again. So in this region, here we have constant deceleration. In this case we have constant acceleration, and this is very, very important. This is the same thing as the increase in the gradient, but this increase was in of course the distance was increasing, and here the distance is decreasing but with increasing rate. So this is very, very important to understand, that when the rate is increasing, it means that the velocity is increasing. And this is what we are writing here, that the point from C to D is red, and this is what we have discussed here, the acceleration in the opposite direction. I have already explained this point, so I need not to go in detail again. Negative acceleration only in terms of opposite direction. So I have already explained this point as well, that negative acceleration is not always deceleration. Negative acceleration may be the opposite direction. Yani a negative acceleration is showing you the acceleration in the opposite direction. So negative acceleration is very important term. Sometimes this negative acceleration means again will be the decrease in acceleration, yani deceleration, and sometimes this negative will show you only the direction change. So here only the direction is changing. Now as far as the E to F is concerned, again you can say that the displacement is decreasing with constant rate. So I have already explained that from your point E to F, the velocity is constant, but the displacement is decreasing because you are coming towards O. So this displacement, which is basically the final, you can say, displacement, is decreasing. Yani you are coming towards the origin, and when you are suppose somewhere here, the displacement is less, but if you are somewhere here, the displacement is more. So you are coming towards the origin, but as I said that what is happening, the displacement is decreasing, but what is happening? Constant rate. So simply you can say that in this case again velocity is negative in terms of direction only. Velocity is negative in terms of direction only. So this is very important. And as velocity is constant, thus acceleration will also be zero, because I have already explained that v minus u over t is acceleration. But if your u and v are constant throughout the motion, then acceleration will be zero. So this is very important. This will be the condition when v is equal to u. When v is equal to u, then what will happen? The acceleration will be zero. So this is important. And if you have understood this graph, then in the next lectures I will give you more details of these graph, and we will discuss more you can say cases, different cases where the graph will describe a particular velocity. But I have chosen this graph because in this graph we have different parts, and these all different parts are explaining you what is happening during a particular time interval. So be careful about the concepts, and I hope you have understood this discussion. So be careful and continue with this discussion inshallah in lecture 4 and other lectures. And I will discuss these points again in detail, that how you will explain the displacement time graph. As I said that if you have a graph and you want to describe the motion, this is what we have done today, that we have a graph and we have described the motion of the body with the help of this graph. So inshallah in the coming discussions we will have motion, then we will describe the graph, or we will draw the graph and so on. So you can write, instead of describe, you can write draw the graph. Any motion, description of the motion is given, and you will draw the graph. So this is what we have. So inshallah, see you in the next lecture. If you are new on my channel, then subscribe this channel, press the icon of the bell, and like and share this channel as well, so more students can get benefit of it. And if you want to you can say get good results, so just follow this channel, and all lectures will help you to get the good results and good marks inshallah. After this we will discuss the numerical problems as well. Till the next lecture, Allah Hafiz, take care.